So the next problem is consider the system h of z equal to 0.2z divided by z plus 0.4 into z minus 0.4. Find the impulse response of the system and why does DTFT exist for the system and find the DTFT. So if you see this question, you want to find the impulse response using DTFT. Okay, so previously we have seen we have find the impulse response is a transform. Here in the last step you want to find the DTFT. So first they didn't mention any procedure, so you can easily find the impulse response h of n by using Z transform. So what is the first step? Find the impulse response of the system h of z. So write the given h of z. Next you want to, here you can solve using the partial fraction method as we have seen in the previous method. So we have find the a value partial fraction method badi simplify பண்ணிக்கோங்க. So from this find the value of h of z by z and find a and b value. Two denominator terms are there, you want to find a and b separately. So first find a value. So a value was minus 0.33 and next we want to find b value. By simplifying you will get b is equal to 0.33. So you can substitute a and b value in h of z and you can find the value of h of z. So now apply the inverse z transform. So we will get minus 0.33 0.4 the whole power n u of n plus 0.33 0.2 the whole power n u of n. So next we want to find whether DTFT is exist for this system. So in order to find that, so here there are two denominator terms z plus 0.4 and z minus 0.4. So you want to find the pole terms from the denominator. So the first pole is 0. That is from z plus, you want to equate the z plus 0.4 to 0. So you will get z equal to minus 0.4. So this is the first pole. And next equate the second term to 0 and you will get the second pole value. So now see the first pole value, second value, you want to draw one unit circle. Or unit circle na enadhu one in ulla place la or circle draw panna. So if you draw this unit circle and find whether this minus 0.4 and 0.2 lies inside this unit circle. If both minus 0.4 and 0.2 lies inside the unit circle, then DTFT exists for the system. Can you understand? And now you can find DTFT. So how will you find DTFT? No, frequency response. That correct? So first itself I said you, if you replace z equal to e power j omega, then you will get DTFT. So in the place of, we have find h of z. So in the place of z, substitute e power j omega. Then you will get the DTFT value. Okay. And next problem, find the frequency response of a first order system y of n minus 1 plus x of n. Plot magnitude and phase response for a is equal to 0.5. So first write the given question a y of n minus 1 plus x of n. So now apply DTFT. So if you apply DTFT, Z transform la எப்படி apply பண்ணும்? A into Z power minus 1 into y of Z ன்னு எழுதுவோம். சரினா? So same thing, here also same formula only. In the place of Z you want to replace e power j omega. Z இருக்க இடத்துல என்ன replace பண்ணணும்? E power j omega. So now if I apply DTFT for the system, it become y of e power j omega. Here a is the constant. So if you apply here Z inverse நாங்க Z transform ல here e power j omega inverse y of e power j omega plus x of is in terms here in the place of z you want to substitute e power j omega because it is DTFT. Okay. So now from this two term you can take this term to other side. So from this two term you can take y of e power j omega outside. எடுத்தீங்கன்னா இந்த வேல்யூ கிடைக்கும். So now what is our transfer function formula? Transfer function is, so frequency response கண்டுபிடிக்கணும். So here they have asked to find the frequency response. So the value is equal to h of e power j omega, that is y of e power j omega divided by h of x of e power j omega. So you will get this value. So இந்த value நமக்கு கிடைக்கும். புரியுதுனா? So in denominator there is e power minus j theta. So what is e power minus j theta? Cos theta minus j sin theta. So write that value, and in the question they have given the value a as 0.5. So now substitute a as 0.5. So I will get h of e power j omega. இதான் frequency response. Okay, frequency response கண்டுபிடிக்கிறதுக்காக we have find frequency response. And another one term they have asked to find the magnitude response. So what is the formula for magnitude response? There is in numerator root of real part square plus imaginary part square. Here also real part square plus imaginary part square. So here this is real part square 1 minus 0.5 5 cos omega is the real part and imaginary 0 point sin squared omega. So take the square and you will get a minus b the whole square is a squared minus 2ab plus b squared. So you will get this term. So now from this two term take 0.25 as common. So you will get cos squared omega plus sin squared omega. So we get the answer. Idha namakku enadhu in a value. We get the magnitude spectrum. Okay, so now the magnitude spectrum answer is, so 1 plus 0.25 is 1.25 minus root of 1.25 minus cos omega 1 by. Okay, so now next you can find the phase spectrum. So how will you find phase spectrum? Angle of h of a per j omega is tan inverse imaginary by real part, that is 0 by 1 term. Okay, so minus, so இது வந்து numerator term, minus denominator term எழுதும்போது tan inverse 0.5 cos sin omega divided by 1 minus 0.5 cos omega. Okay, so now tan inverse 0 value is 0. So this value is tan inverse, write this value and now substitute different values for omega. So different values omega substitute பண்ணும்போது magnitude இந்த மாதிரி value கிடைக்கும். So magnitude நமக்கு இதில் omega இருக்க இடத்துல you want to substitute different values. Okay, pi by 2 இதெல்லாம் substitute பண்ணு. எங்க omega இருக்க இடத்துல அதே மாதிரி substitute பண்ணும்போது you will get this value. So now plot it. So here pi by 2, here the phase value and here you want to plot this value 0.60, 0.89. Okay, and plot it and here also இது என்னது நமக்கு phase value. Okay, so எல்லாம் plot பண்ணு. So the next question is, a causal system is represented by the given equation y of n plus 1 by 4 y of n minus 1 which is equal to x of n plus 1 by 2 x of n minus 1. Find the system function h of z and obtain region of convergence. Okay, so system function transfer function only da. Okay, so if they ask to find system function h of z, transfer function is also h of z. Okay, and now if you see the next question, find the unit sample response, that is the impulse response. The other name for unit sample response is impulse response h of n. And next they have asked the frequency response. So DTFT use pannu. Okay, h of e per j omega determines its magnitude and phase. So first you want to find the transfer function h of z. H of z find panna namakku theviyana y of z and x of z. So first write the given question, given difference equation and now take the z transform and next find y of z by x of z. So we will get h of z. h of z தான கண்டுபிடிக்க கேட்டிருக்காங்க first. Okay, system function h of z. They asked to find the region of convergence also. So here you know the denominator term is z plus 1 by 4. Okay, so z plus 1 by 4. So here the z value will be, so if you take what is our region of condition, region of convergence condition. So according to our region of convergence, here the z value is greater than 1 by 4. Okay, so refer the region of convergence topic, then you will understand here. So it lies beyond the unit, that is 1 by 4 value. Okay, greater than 1 by 4 value often. So இது வந்து வெளியில நமக்கு lies ஆகும். Okay, 1 by 4 விட வெளியில region of convergence. So it is our diagram. Can you understand? And now, so next you want to find the unit sample response. Okay, in order to find the unit sample response, what is unit sample response? Impulse response. Okay, we know h of z value is this one. So here we got z plus 1 by 2 divided by z plus 1 by 4. So now, so listen, z plus 1 by 4. We can separate the numerator term z plus 1 by 2 as z by z plus 1 by 4 plus 1 by 2 by z plus 1 by 4. Okay, so we have separate this term and now if you say, you can multiply the second term with one z and z inverse. So if you multiply this term, you can apply the time shifting property here. Okay, so in order to apply the time shifting property, or you can't solve directly 1 by ன்றதுனா டைரக்ட்டா சால்வ் பண்ண முடியாது. ஸோ டைம் ஷிஃப்டிங் ப்ராப்பர்ட்டி அப்ளை பண்ணணும்னா ஈஸியாக நமக்கு இசட் ட்ரான்ஸ்ஃபார்ம் எடுத்துடலாம். அதனால தான் நியூமரேட்டரில் ஒரு இசட் அண்ட் இசட் இன்வர்ஸ் மல்டிப்ளை பண்ணுறோம். ஸோ நவ் யூ கேன் அப்ளை த டைம் ஷிஃப்டிங் ப்ராப்பர்ட்டி ஹியர், தட் இஸ் இசட் by z minus a into z power minus k. The property is a power n minus k into u of n minus k. So you want to apply the value. So here the value is a power n into u of n. So a power n. So அந்த u of n இருக்கனால தான் நமக்கு இங்கே region outsideல இருக்கும். So இதுக்கு region of convergence draw பண்ணும்போது நமக்கு it lies inside the pole circle. Okay. So here the value is minus 1 by 4 the whole power n u of n plus 1 by 4 minus 1 power n minus 1 of n minus 1. Okay, so next you want to find the frequency response. In order to find frequency response, replace z by e power j omega, and after replacing e power j omega, the value is cos omega plus j sin omega. And now rewrite the term, that is real part separately and imaginary part. Then it is easy to find magnitude response. So what is magnitude response? Root of real part squared plus imaginary part squared. Here also find the in denominator also find it, same thing, and apply a plus b the whole squared formula, rearrange it, and you will get the value as root of 1.25 plus cos omega. Okay, and face value is tan inverse imaginary by real part. Okay, this is for numerator and this is for it is for numerator term and it's for denominator term. Okay, so by applying different values for omega, minus pi by 2, 0, pi by 2 pi. Okay, for magnitude spectrum you will got this value, and phase spectrum you got this value. So plot this in magnitude and phase spectrum. So this is about the difference, how we can solve when difference equation is given, means you can solve using the DTFT. If they ask magnitude, means you want to substitute different values of omega and you want to find the magnitude spectrum and phase spectrum and you want to plot it. If they ask to find the frequency response, means you can solve using DTFT. If they ask to find the impulse response, means you can solve using Z transform. Okay.